All right, so hello and welcome everyone to week 11, the second last week of interactive live sessions for the course on Computational Fluid Dynamics for Incompressible Flows. The course is being offered by NPTEL. It's being instructed by Professor Amaresh Dalal from the Department of Mechanical Engineering at IIT Guwahati. My name is Debjit. I'm a PhD scholar at IIT Madras, and like every other week, we shall be solving some problems together. Now, in that regard, let me tell you today is week 11, right? So, week 12, we will have a class next Tuesday and next Wednesday. So, this Tuesday would be 16th, I guess. And then on 17th, we will have another uh, revision session of all containing covering materials of all the 12 weeks. And if you have any doubts, bring them. And these will be from our usual timings within 6 to 8. Okay, so this class will be an extra one, a revision class on 17th. So take note of that and we'll meet then. Okay, so let's get started with today's session. So this is our first question, which is asking us that for momentum conservation, the 2D steady convection diffusion equation is what? Is it linear, non-linear, or is there not sufficient information given in the question? So week 10, we started talking about the finite volume method, and on week 11 also we will continue with that. And in week 13, we will discuss some convection schemes which are used for finite volume methods. So the course was organized in this way that for weeks 1 to 9, it was finite difference method, and from weeks 10 to 12, we had a brief discussion or brief introduction to finite volume method. I guess there are other courses available online which only cover finite volume method. So this gives a brief introduction to it. If you are more interested in learning, I'll suggest you to go through them. Okay, back to our question. Is the 2D steady convection diffusion equation linear, non-linear, or insufficient information? Okay, we have one quick response in favor of option B. Let's hear what others have to say. Sorry. Is it possible to upload this class video by today night for this session only? Yes, I will try to upload this by tonight. Okay. So we have multiple responses in favor of option B. Let's have a look at the solution, which we did peek into briefly due to my clumsiness, and indeed it is non-linear. So the 2D steady convection diffusion equation looks like this. So dou x of rho u plus dou y of rho uv equal to dou x of gamma, sorry, not gamma, I'll write mu here, dou x plus dou y, and if you consider the pressure difference, then a source term will be there, otherwise this is it, convection and diffusion. So, and this thing is non-linear because of these terms. So these terms are the ones which brings in non-linearity to fluid mechanics, and that creates all the beauty which fluid mechanics has to offer. Because otherwise it will be just a set of boring linear equations, right? This is what makes fluid mechanics interesting as well as unsolvable to this date. So there is no general analytical solution to these Navier-Stokes equations, and there is this Millennium Prize which is offered to whoever solves it first. And this is also the reason why we do CFD in the first place, because since we don't have any general analytical solution to it, we have to discretize it and try to obtain solutions in a numerical manner. Yeah, any questions?
Yeah, actually, it's the last question. Actually, a little basic one again,
Yeah,
and
sure.
related to linear and non-linear only.
Hmm.
Yeah. So, like there is once there is exactly what we define non-linearity in multiple ways. Like there's a level of non-linearity, like from semi-linear, quasi-linear, and then we go for fully fledged non-linear equations,
No,
right?
thing is,
So,
no, see, mathematically, one equation can be either linear or non-linear. Now, few non-linear problems can be approximated as quasi-linear, in which some mathematical approximation is plugged into it to make it uh, linear.
O- Okay, okay. So, like for 1D, the definition is a bit different.
Mm,
Like, I mean to say, first order for first order equation,
mm,
the definition for this thing, linearity, and from beginning from linearity going to full that non-linearity,
mm,
we have a different definition, and similarly, like for non-linear, when we go for higher orders, like for second and third order, the
mm.
difference is like if we have a quasi-linear equation, then the multiple should be of lower order than the highest order derivative possibly.
Can you give me an
Right? Such kind
example?
of definitions
Yeah,
are there.
can you give me an example of a second order quasi-linear or semi-linear equation?
Uh, like I need to, actually, I have not opened it. I need to find it a little bit. Like,
Mhm. So,
just a minute. Just
so
a minute.
it's a
Just two
second
minutes.
order. So let's do dou x square, and there can be u square in between. So this is non-linear.
Yeah.
On the
Just
other hand, if
1
I
minute.
have,
Just I'm opening.
yeah, please look into it. On the other hand, if we have this is linear.
Yeah, here it is. Just a minute. Like, what basically happened that I don't understand. Like, basically, what I am trying to ask is like there is not a clear definition what I get for finding the non-linearity, because as the order changes, they had I found that something is different. Like,
Uh,
like
See, thing is, if you have, so you'll have to forget about all the derivatives and just look at the variables in question. So in this case, you'll have to forget about all the x's and y's and look at the u's and v's. So if any u or v is getting multiplied by itself, or u is
uh,
getting multiplied by v, so the order of that, if it is 1, then it's linear. If it's getting multiplied by either u or any derivative of u, then it would make it nonlinear. That's it, clear cut definition,
oh,
nothing in
okay,
between.
yeah. So the like it is. Yeah, the thing is like what I'm trying to ask, like we only look into the higher order terms. Let's say if we have at the
Hmm.
second order equation, then we only have a look into del square phi upon del x square terms, or del square y upon del square phi upon del y square terms. Like lower order terms, we don't
No,
look
no,
into
no.
it, and
In the
we see there.
I'll give you a counter example. In the Navier-Stokes equation itself, there is a second order derivative, right? But then again, that's not
Yeah.
nonlinear. That is totally linear. But the nonlinearity is in the lower order term, which is the first order derivative. That also makes the entire equation nonlinear. It doesn't have to be at the highest order.
Can you just give me a fine definition of what is linear non-linearity?
Nonlinear is that if any term is multiplied by the term itself or any derivative of it. So
No,
the
what does it physically means? Because
yeah, so okay, physically defining this is very difficult, but what it means is that within the equation there will be the terms itself or the derivatives of that term itself. So if we consider phi, so then there will be phi dou phi dou x dou 2 phi dou x. That's it. There won't be any phi dou phi dou x or dou x of phi square. Anything like that won't be there.
Can I make this? Yeah, can I make this conclusion that linearity and non-linearity is only a mathematical terminology? It doesn't
Yeah,
have
of
any
course, it
in,
originates mathematically only.
no, no, but I can't extend it physically. There is a limitation that it
I
has
can't
only has a
explain it
mathematical
to you
sense.
right now, but that doesn't mean it doesn't have physical implications. It has very real physical implications. See,
The
the thing is,
implication is one
see,
thing.
yeah,
Okay, yeah.
I'll tell you what. So the solutions of linear equations can be superposed on each other. So if I just write down one linear equation and you write this, and let's say I have solutions of it, u0, u1, u2, multiple solutions. So then I can also say that any other u, which is a linear combination of these individual solutions, this will also satisfy the original equation. But that's not true in case of a nonlinear equation.
Okay.
Okay,
Yeah. It is a feature for
it
of
is a feature.
linear equation. Yeah, but what like can you write one equation, please? I just
So
a plus
what a
a
plus hmm,
I'm del no just a del square
a del square
5 del
of
square no, x x no, no don't not this del it's d del yeah this kind of d square upon dx square
hmm,
del s square yeah plus b del square pi upon del x del y.
oh del
Okay,
x del y.
del x del y actually.
Okay.
Yeah. Then plus c
Hmm,
del square pi upon del y square
hmm,
plus d uh, del pi by del x plus e. Yeah, continue. Full
okay.
equation. Yeah, f5 plus g f5 plus g f5 plus g is equals to 0. Yeah,
Okay.
this is a full-fledged like
Yeah.
equation.
Hmm,
Like here, if we I need to decide the non-linearity, I look into only ABC, and I say that if
hmm.
this ABC is either a function of phi or lower derivative of phi, like del phi by del x or del phi by del phi, then it is non-linear, right?
No, 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 no. Even if it's a lower order derivative, then also it will make it nonlinear. This, if they are equal to phi or dou phi dou x or dou phi dou y or any higher order derivative.
Okay. No, higher order will change the degree of equation actually. So, okay,
Up to the
that
second
is
order.
also
So it's a
non-linear,
second
but
order equation up to the second order. If it's there, then only it becomes nonlinear. There cannot be anything related to phi within all these.
okay, okay,
Okay,
okay, okay. Thank you.
no problem. Okay. Any other questions, anyone? All right. So if there are no questions, we'll move along. We'll move on to question number 2 now, which is asking us select the correct statements related to the Scarborough criterion. Where if I say that R is equal to this summation of the mod of A and B divided by AP, then which options within this are the correct statements related to the Scarborough criterion? Is it option 1 that r less than equal to 1 for all points? Option 2, r less than equal to 1 for at least 1 point. Option 3, r less than 1 for all points. And option 4, r less than 1 for at least 1 point. So there are these 4 statements which I read out, and there are different combinations in the 4 options here. So option A is 1 and 4, option B is 2 and 3, option C is 1 and 2, and option D is 3 and 4. So you'll have to pick the correct combination from here. So we have one response in favor of option A, that is 1 and 4. Let's hear what others have to say. So A means 1 and 4. Okay, so let's have a look at the solution. It is actually option 1. So according to the Scarborough criterion, for convergence, R has to be less than equal to 1 for all points, and for at least 1 point, this has to be less than 1. So it could be that at all points R is equal to 1, and at only 1 point, if it's less than 1, that itself is sufficient for uh, convergence, for assuring that there will be convergence. This is just to ensure diagonal dominance, and uh, if you use any solution scheme, you are guaranteed to get convergence. Any questions on this? Okay, so if there are no questions, we'll move on. Yeah, I'm unable to hear you. Sorry, let me interrupt. I'm unable to hear you. Your voice is breaking up. Can you try again? Oh, okay. So the derivation of Scarborough criterion is not there. You'll just have to know what it is. So basically, uh, the equations after discretizing in finite volume method sort of boil down into these forms. So where AP phi P is equal to A and B, phi and B plus some B, which takes care of the source term. So for convergence of this, the summation of these phi NBs, rather the mod of these, the values of these phi NBs, absolute values, and the absolute value of AP, this has to be less than 1. So basically, this has to be less than equal to the absolute value of AP for all points, and for at least one point, it has to be less than AP. So these two constitute the Scarborough criterion that just guarantees convergence. There is a mathematical derivation of it, but that's beyond the scope of this course. Okay, any other question? Anyone? All right, so let's move along. We'll move on to question number 3 now, which is asking us that for convection diffusion equations, what is done to ensure that Scarborough criterion is satisfied for convection diffusion? Is it option A, upwind scheme is employed, or option B, central difference scheme is employed, or is it option C, Crank-Nicholson scheme is employed, or is it option D, none of the above? We have one quick response in favor of option A, that upwind scheme is employed. Let's hear what others have to say. Okay, let's have a look at the solution. It is actually option A. So the upwind scheme is employed. There are different orders of upwind schemes, but the main use of employing them is that the Scarborough criterion gets automatically satisfied, and as a result, your convergence is ensured. So what does upwind scheme means? So let's say if I have a 1D domain like this, so this is small e, p, sorry, this is small w, capital W, small e, capital W. So let's say at point E we are interested in. So we're trying to find out what Fe phi E is. Now if the flow is going from left to right, then we will assume that phi E should be equal to phi P, that is the point upwind to it. Similarly, if the flow is going from right to left, that is if u is less than 0, u greater than 0, x in this direction, then we will go upwind towards this, and sorry, this is capital E. So in that case, we will assume phi E to be phi capital E. We will consider the point upwind to it. So this is first order upwind. There are second order and third order upwind schemes as well. Doing this ensures that all the A and B's are smaller than AP, which is the Scarborough criteria. Okay. Any questions on this? All right. So moving along, we move on to question number 4 now, which we just discussed. So for first order upwind scheme, what is the most general way of estimating Fe by E? Yeah, I see a question in the chat box. Interpolation. No, not really interpolation. It's just taking 2 points, taking either point in the upwind direction. Now, if there is, if we use interpolation, then that is called a mean value approximation, and that becomes a central difference. That is not upwind. So, in that case, so in this case where we have, sorry, we have P here and E here and small e over here. If we interpolate P and try to find it as the average of phi P and phi E, then this is a central difference, not upwind. Okay. So we have one response in favor of option C, that it should be Fe phi P minus Fe phi E. Read the question carefully. So for first order upwind scheme, what is the most general way of estimating Fe phi E? Is it option A, Fe phi P? Is it option B, Fe phi E? Is it option C, Fe phi P minus Fe phi E? Or is it option D, the maximum of Fe comma 0 into phi P minus the maximum of minus Fe comma 0 into phi E? So this function is maximum function. So it just, if it is A comma B, then it will just give you A if A is greater than B. This will give you B if B is greater than A. We have one quick response in favor of option C. Let's hear what others have to say. Okay, so let's have a look at the solution. It is actually option D. So this is something which we discussed in the last question. So I'll again draw the same thing. So I have P, E, and W here, and let's say we are trying to find out small e. So this W is also not required. So this is our grid. Now Fe phi E has to be determined. So when U is greater than 0, that is flow is from left to right, we pick the upwind point of E. So then phi E, so then Fe phi E would be simply Fe phi P, and if U is less than 0, then we will again pick the upwind point which is in the right side of it. So if the flow is going this way, then the upwind point would be capital E, then it would be Fe phi E. Now it depends on if the value of U, whatever it is, right? And Fe we know is actually rho into UE into AE. So if U is positive, Fe is positive. If U is negative, then Fe would be positive. F carries the same sign as U. So that we can use, and then we can write this general form as the maximum of phi e comma 0 into phi p. So this will come into the picture when u is positive, or similarly fe is positive. The other one would vanish then. The other term would be the maximum of minus fe comma 0. So within these two, 0 is the maximum. So let's have a look at the two situations. So if fe is greater than 0, meaning u is greater than 0. So this would then mean that fe phi e would be equal to fe phi p minus 0 into phi e. So this term won't be there. Similarly, if u is less than 0, consequently fe would also be less than 0. In that case, the first term over here would be 0 into phi p going to 0, and the second term would be minus. Now maximum of minus fe and 0, minus fe is greater. So it will be minus fe into phi e, because since fe is negative, minus fe is a positive number, and that is greater than 0. So this just boils down to fe into phi e, phi capital E, sorry. So you see that these two we get, right? Both of these situations are handled by this one equation. So that's why this is the most general way of writing fe phi e. Any questions on this? So it's a bit of a mathematical manipulation to just write the entire thing in one line. Okay, so we'll move on to question number 5 now, which is asking us what is the order of accuracy of the quick scheme. The quick scheme is the abbreviation of quadratic upwind interpolation for convective kinetics. Q U I C K, quick. What is the order of accuracy of it? Is it 1, 2, 3, or 4? We have one response in favor of option B, that is 2. Let's see what others have to say. Option B, option B. Okay, there is one answer in favor of option C, that is 3. Okay, so let's have a look at the solution. It is actually 3. Good. The thing is, in the quick scheme, so it's called quadratic because the second order term is also considered. So let's say if we are trying to find out phi e for the case when uh, let's say u is greater than 0. So this is our template. I won't draw boxes, I'll just write down the points. So this is P, this is small e, this is capital E, then this is small w and capital W. So let's say when u is greater than 0, so then my upwind point is P. So with respect to P, I'll write this as phi P plus, and this distance is delta x, this distance is delta x. So del x is actually delta x by 2, right? So while doing this, I'll just use delta x over 1 factorial into dou phi dou x at P plus delta x squared divided by 2 factorial into dou 2 phi dou x squared at P plus higher order terms, which is of the order 3. So in quick scheme, up to this quadratic term is also considered, and the higher order terms from the third order onward are ignored. So that's why the order of accuracy is 3. Okay. Any questions on this? If not, we will move along. We'll move on to question number 6 now, which is asking us that for that quick scheme, the formula which I just wrote, how is phi e represented? So there are mathematical forms of phi e. You'll have to find out which one is correct. Take your time, and so we had the hint over here, so we'll have to use this. So I'll just write this down again. So phi e is equal to phi p plus del x. I'll just write this simply. So since del x is delta x by 2, so this is delta x by 2 into dou phi dou x at P plus this square into 1 by 2 factorial into dou phi dou x at P plus higher order terms. Ignore them. Just plug in the derivatives dou phi dou x at P and dou 2 phi dou x2 at P, and then you should arrive at the correct equation among these. Okay, we have a question in the chat box. Question number is non-linear, but its order is 2/3. Question number 1 is non-linear, but its order is 2 or 3. It's order 2. So in question number 1, what we had is the convection diffusion equation, the momentum transport equation. So it's just uh, sorry, dou dou x of rho u square plus dou dou y of rho u v equal to dou dou x of nu into dou u dou x plus dou dou y of nu dou u dou y. So these two are second order terms, right? So the order would be 2, and these two are order 1 terms. So the highest order is 2. Okay. Okay, so back to question number 6, which would be the correct answer. Okay, so if we carry along, so this is phi p plus delta x by 2. Now dou phi dou x, we can write it as dou phi dou x at p. Just draw the template here. So this is at p, and we have u greater than 0 in this direction. So using central difference, dou phi dou x at p should be uh, Pe minus phi w divided by 2 delta x, and this second term, the second derivative, there we will have dou x squared divided by 8, because 2 into 4, sorry, 2 square 4 into 2, 8, and the second order derivative with respect to using central difference scheme would simply be dou w minus phi w minus 2 phi p plus pe. This delta x square gets cancelled, this delta x gets cancelled, and we are left with, okay, so I'll write this from here, phi e would be equal to phi p plus e minus w divided by 4 plus pw minus 2 phi p plus pe divided by 8. Now just collecting terms, so first of all we will write phi e. So phi e, we have 1/4 from this term and 1/8 from this term. So 1/4 plus 1/8 is 3/8. Then we will do this for phi p. Phi p, we have 1 here and minus 2/8 or minus 1/4 there. So 1 minus 1/4 is 3/4. And phi e, we have minus 1/4 here, sorry, phi w. We have minus 1/4 and plus 1/8. So that would be minus 1/8. Right. Minus 1/4 plus 1/8. Yeah, minus 1/8. Yes. So it should be option A. Let's have a look at the solution. It is actually option A. So here's the solution, how to work this out. If you have any questions, please ask. All right, so moving along, we'll now move on to question number 7, which is asking us which terms are absorbed into the flux term J while integrating the governing equations. Is it option A, the transient term and convection term? Is it option B, the convection term and diffusion term? Is it option C, the diffusion term and source term? Or is it option D, the convection term and source term? So this is something which we had discussed earlier. So everyone is quickly responding towards B, convection and diffusion term, which is indeed correct. So just writing things out once again, the governing equation looks like this. So dou phi dou t plus there is some rho u into grad p, is it? No, sorry. So into grad into u phi plus equal to the grad of gamma grad p plus some source term. Now these two terms can be combined. So I can write this as del of rho u phi. So rho will also be inside if it's a variable, then rho can also be a variable of space, right? So in that case, it would be inside this grad, and minus gamma grad phi equal to sp. So this I can now call as grad of j. The convection term and the diffusion term both give rise to the flux term. Any questions on this? This should be an easy one. Okay, so moving along, we move on to question number 8 now, which is asking us what is the correct expression for Sell-Peclet number? Is it option A, rho u delta x by gamma? Is it option B, rho delta x by u gamma? Is it option C, rho u by gamma delta x? Or is it option D, u delta x by rho gamma? So I'll give you a hint. What is Sell-Peclet number? It is actually equal to the convective coefficient divided by the diffusive coefficient. We need to know the forms of this Fe and De to find out what the Sell-Peclet number is. Fe we saw earlier. What is it? Rho into U. So F E suffix C. Rho U suffix C into A suffix E. And De is the diffusion coefficient, which is gamma into phi E. Okay, no, phi E won't be there. Okay, there is a power cut here. Amazing. Yes, second. Sorry, there was a power cut here. I'm again sharing. Just let me know if you can see the screen. The screen is visible, right? Hello. Am I audible in the first place? Okay. Uh, all right. So back to our questions. Sorry about that glitch. There was a power cut here. Anyway, so the Peclet number is the ratio of this Fe and De, and I've written down Fe and De for you almost. So gamma by this into delta x into AE. No, sorry. AE would be up here. Okay. PE won't be there. Gamma into AE by delta x. That's it. Yeah, so let's have a look at your answers. They're all in favor of option A, which should be correct. So PE, if I now, okay, so PE, if I now try to write FE by DE, FE, which was rho U A divided by dE, which was gamma A by delta x. A and A would get cancelled. This would just give me rho U delta x by gamma, which is the first option. Correct. Okay. Any questions on this? If not, we will keep moving along. We move on to question number 9 now, which is asking us that what is the requirement for the cell Peclet number so that again Scarborough criterion is satisfied. Is it Peclet number equal to 1, Peclet number less than 1, or is it Peclet number Peclet number equal to 2, less than 2, greater than 2, or none of the above? We have one quick response in favor of option B. Awesome. So basically, any AE can be written as is correct. No. So the idea is that this cannot be allowed to be negative. If it's positive, then I know for sure that all the summation, so summation A and B would be equal to AE plus AW plus AN plus AS, right? So if I want to satisfy this Scarborough criterion, all of these, if I ensure are positive, then this A and B would definitely be greater than all of these individually. But if one of them are negative, then that boundedness is violated. So my idea is that each of them have to be uh, positive. So for that, this has to be greater than 0. So then if I uh, manipulate this, so I'm left with Fe by dE less than 2. Right? So I'll just take it that side. Fe by 2 should be, I'll just write the steps in between. So Fe by 2 should be less than dE. dE I'll bring down and 2 I'll send up. So Fe by dE is less than 2. Finally, this can be written as the Peclet number should be less than 2. And it is indeed the correct answer. So this is the solution here. Any questions on this? Okay, so if not, we will move on to question number 10 now, which is the last question. So at convergence, what is the value of the convective of the sum of the convective coefficients? So is it option A, summation of them should be equal to 1? Is it option B, less than 1? Option C, greater than 1? Or is it option D, equal to 0? No, not really. Not Reynolds number, no. So Reynolds number is basically the ratio of the inertia force by the viscous force. And Peclet number in general, what it means is that transport through convection by diffusion. And in case of cell Peclet number, it means within the cell how much is being convected to the ratio to how much is being diffused. So yeah, in a sense, inertia and convection and viscosity and diffusion are related. So the mathematical form looks familiar to each other. But in general, in case of fluid flow and heat transfer, Peclet number has a different meaning than Reynolds number. Okay. So what happens to the sum of the convective coefficients, which is Fe minus Fw plus Fn minus Fs, equal to what at convergence? Is it equal to 1? Is it less than 1, greater than 1, or equal to 0? Yeah, so here's the summation equation, and the individual values are, say, rho UEAE, then rho UWAW, and Fn would be rho VNAN minus Fs would be rho VSAS. So if this is our control volume, and this is UW, this is UE, this is Vn, this velocity is Vs, and the areas are AE, AEAW, AN, and AW. And rho is the density of the fluid. So physically, what does this mean, this summation? See, if you look at this, uh, UE and Vn, these are the velocities carrying flux out of this fluid, right? So this is going out of this control volume, and these two are coming into the control volume. And the net sum of that is this summation FF. What should that be at convergence? What is the net influx or outflux of a fluid in at convergence? And remember, this is for incompressible flow. So rho is constant. So at convergence, what do you think? At a control volume, is there any net influx of fluid or any net outflux of fluid? At convergence, it's actually zero, right? So there is no net influx or outflux. Whatever comes in goes out. The total amount of fluid within it has to be constant, right? Because of mass conservation. Mass conservation principle. Whatever comes in goes out. So there is no net influx or outflux. So this has to be zero, and this can actually be mathematically shown that this is uh, actually it's the continuity equation only. So ue minus uw by something should give you dou u dou x, and similarly vn minus vx vs would give you something like dou v dou y equal to 0. So this is just the continuity equation being satisfied. So it's option D, which should be the correct answer. Okay. Any questions on this or anything else which we discussed so far? Okay. So this was last question from my end. Thank you all and good night. And we will meet again next week on 16th as well as on 17th. Okay. For discussion of week 12 questions as well as one revision session. Okay. So thank you all. Bye. Good night.